Okay, so I want to walk through a electrical system diagnosis with you, and I want to talk a little bit about how wiring diagrams work at the same time. So first we're going to talk a little bit about reading a wiring diagram. So in other electrical videos we've talked about how electrons move from negative to positive, but a lot of technicians also talk about it moving from positive to negative, and it's an old theory that's been disproved, but people still kind of talk like that. And then what gets confusing is our wiring diagrams are written from positive to negative. Now that doesn't mean that they're written showing you that that's how electrons move, it's just that's how the flow of the chart works. We have one wire coming, or two wires coming from the battery to a fuse panel, and then we branch out and go to all these things and have a bunch of different grounds. So rather than having it funnel like this, it's easier to show power comes here and write the flow coming off. So when we talk about it, we say, okay, current's flowing through here, we're moving from positive to negative, and when I say current's flowing through here, we know it's moving, the electrons are moving that way, we're just reading the diagram in the flow from positive to negative. So that's something very important to kind of keep in mind. So how do we read a diagram like this? Now I've redrawn the diagram exactly how it is when we print it off with the service information, so it's larger for you to see. So how do we read it? Well, typically I like to kind of find my powers and grounds. So we see that we've got a battery positive power here. Usually it's at the top. This one's coming in from the side, then going up, then coming down. So we got battery positive, so that's the start of the flow of our diagram. And then we have a ground. So, okay, we see a ground here, and a ground here. So this is where there's going to be sort of some finish of the flow of our diagram. So I like to do that first, so I kind of know where I'm starting and finishing. Then I like to look at components. So what are we actually running here? Well, we see that we've got the symbol for a motor there. So we've got a motor, and it says starter beside it. So this is the starter circuit that we're looking at. So that looks like the only major output that we're controlling is a starter. And then we've got some other modules that are working here. So we've got an ECM, electronic control module, that's controlling part of the circuit. And this here looks like I forgot to write it on, but it said this was the fuse block under hood. Okay? So we've got just the fuse block, we've got ECM, and we've got some other components here. Okay, that's a relay. We've got a solenoid down here at the starters and things that kind of look a little funny. We've got some fuses and stuff like that. So we're kind of starting to get a picture of what we've got here. You can ignore this for now. That's something I'll talk about later. I drew that there. That's not actually part of the diagram. So, all right, so let's start and let's see. So we've got battery positive. Well, what happens here? Well, we've got a connection from battery positive directly to the starter. Now, because it's battery positive, we would call that hot at all times. Doesn't matter if the key's in or not, we always have connection from here to the starter. So why isn't it cranking all the time if there's connection all the time? Well, that connection stops right here at the starter. And there's a switch right at that starter. And that switch is actually our solenoid, and it's a big contact plate, a big round circle with two contacts. It sucks in. It can handle a lot of current. So if that starter's drawing, 80 amps of current, big thick wire, can handle all that. So there's some sort of switch here that's going to open and close. We're not really sure how yet, right? And we see that there's a ground here. So when that switch is closed, how does this motor turn? Well, we see that current, electrons will move through here, through the motor, through this closed contact in the solenoid, up here to battery positive. So we're starting to see, okay, there's one little chunk there, and that's how it works. But how do we get all that to turn on? That's the tricky part, right? So we kind of got to look out here a little bit more. So we can see that, okay, we have battery positive coming from here, right? So we're going to have battery positive there. Well, that switch is closed too, but we know we at least have battery positive there. And then what's happening else up here? Well, we've got a ground. So we've got a ground here. So electrons are going to move through here. They're going to go through this part of the relay, which we'll explain in a second. But then they have to go to a battery positive source somewhere. And then we see here that we have a battery positive source at the ECM. So the engine control module, one of the computers, is actually going to physically close this switch and allow current to flow this way, but we're going to follow the flow of the chart. So we allow current to flow through here. Okay? So it looks like all these things that link and work together kind of start with this system here. So let's trace that and let's see what happens. So the ECM, okay, physically takes and closes a switch in here, all right? That allows battery positive, so it allows current to flow through here. Yes, we know electrons are going this way, but we're going to do the flow of the diagram. So current flows through here, through this, and to ground. So that's our complete circuit. What is this? This is the load. This is a coil, a winding, inside of what we call a relay. Okay, so a relay looks like this. And inside here, there's a little wrap of a small wrap on a lot of wire, and it's enough wire that it's a load and drops the current down a little bit, and so it doesn't just burn this wire. So we have a load, we have a complete circuit, and current flows through this wrap of wire. Why does it do that? Well, it builds up magnetism. Okay, so when current flows through wire, we build up a magnetic field. That magnetic field builds up around here, okay? It builds up, builds up, builds up, and it physically sucks this switch closed. Okay? So it closes this switch. That's what a relay does. So it uses current on the coil side, or the winding side, to take and suck close a switch on this side. So that switch will now be sucked closed. Now that allows this current that's coming through here. This is a mega fuse, 175 amp fuse. That's a big fuse, not because of the starter, because the current going through here is not what's going through here. That's a big fuse because we see that this fuse supplies battery positive to all of the fuses in the fuse block. So all the current through here and all these other ones that are connected, and it's not showing us what they are, it just shows us that that goes to the rest of them. The whole fuse block is getting its power from this wire. So that's going to be a big wire, big fuse. Okay? But now we have this switch closed. Current can now flow through here, through our specific starter fuse, which is a 40 amp fuse. Okay? And we have current flowing through here, and to, well, this. Well, that looks similar to that. Now that's the sign for a solenoid. So same kind of concept here. We have a bigger wrap of wire around a big iron core that's taken and it's attached to that big plate that I was talking about. So current flows through here, builds up magnetism, sucks this plate closed, and then now this switch is closed, allowing current to flow through here. Okay? So a solenoid and a relay are very similar. Solenoid is bigger and has a bigger iron core that moves and slides. And we do that for two reasons. One, so we have a bigger contact on here to close this so that high current can go through here. But also, that big thing will move and click a little arm out to shove that gear into the flywheel to physically turn the flywheel, because we don't want it engaged all the time. We want to engage when we're cranking and then disengage. So it does two things. It mechanically engages the starter drive, but it also sucks closed a contact plate. Okay, so that's how it works. ECM closes switch. Current flows through here, builds up magnetism, sucks this closed, allows current to flow through here, builds up magnetism, sucks this closed, allows current to flow through here, turns motor, engages starter. Okay? And that all happens like that. Okay? Can't snap my fingers. Okay, so that's how the system basically works. So I think we'll pause it there so that the video is not too long, and that's just a good little lesson on reading wiring diagrams. And then we'll restart again with this diagram and actually look at a problem.